You have seen it happen, and it never quite makes sense. A free kick leaves someone's foot heading wide, clearly missing, and then, halfway to the goal, the ball bends. It swerves around the wall of players like it changed its mind, and curls into the net. Or a pitcher throws a ball straight at the batter, and just before it arrives, it darts sideways and drops, and the batter swings at empty air. And every time, you feel certain the player simply aimed it that way. That somehow the ball knows where to go, but the ball does not know anything. Nobody is touching it. There are no strings, no magnets, no wind machine. And yet something invisible is reaching out in mid-flight and shoving that ball sideways. Once you see what it is, you will never watch a curving ball the same way again. So stay with me. I'm Mr. Why? And let's start with the puzzle. Take a ball and throw it with no spin at all. A clean, dead throw. It sails out in a smooth line and slowly drops, because gravity is pulling it down, and that is the only thing tugging on it. Simple. But now throw that same ball with a hard, sideways spin on it, and something bizarre happens. Instead of going straight, it curves off to one side in the middle of the air, all on its own. Nothing bumps it. Nothing touches it. So here is the fair question, the kind a 5-year-old asks, which is the best kind. How on earth does spinning a ball make it change direction? Spinning should just twirl it in place, like a top. Why does a spin turn the whole ball off its path? And here is the twist, the thing that flips the whole picture inside out. When you imagine that ball flying, you probably picture it slicing cleanly through empty space, steering itself. But the space in front of it is not empty. The ball is flying through an ocean of air, thick and real, swimming through it like a fish. And the ball is not cutting itself sideways through that air. The air is pushing the ball. Here is the secret that makes it all work. A spinning ball does not slide cleanly through the air. As it turns, it grabs a thin layer of air right against its surface and drags that air around with it, the way a spinning wheel would fling water off its edge. That tiny, dragged layer of air is the whole trick. So let's fly along beside the ball and watch what that does. Because the ball is racing forward, there is a wind rushing at it from the front, streaming past both sides. But remember, the ball is also spinning, dragging its little skin of air around in a circle. Now look at one side of the ball. On this side, the air the ball is dragging happens to be moving in the very same direction as the oncoming wind. The two flow the same way, so they add together, and the air on this side goes rushing past faster. Now look at the other side. Here, the dragged air is moving against the oncoming wind. They shove head-on into each other, they fight, and so the air on this side is slowed down and crawls past slower. So without anything touching the ball, it now has fast-moving air on one side and slow-moving air on the other. And that is where the hidden rule comes in, and it is a strange one. Fast-moving air presses sideways less, slow-moving air presses sideways more. It sounds backwards, but it is one of the deepest rules in all of physics. When air speeds up, its sideways push drops. So think about what that means for our ball. On the fast side, the air is pressing on the ball gently, a weak push. On the slow side, the air is pressing on the ball hard, a strong push. The ball is being squeezed by two hands of air, one weak, one strong. And when one push is stronger than the other, the stronger one wins. The hard-pressing slow side shoves the ball across toward the gentle fast side. The ball gets pushed sideways, away from nothing, into the curve. That, right there, has a name. It is called the Magnus effect, and it is the reason every curving ball curves. And once you have that one idea, the whole sports world cracks open, because it is all the same push, just aimed differently by the spin. Spin the ball sideways, and the fast side is on the left or the right, so the ball swerves left or right. That is the banana free kick, curling around the wall. Now spin the ball backwards, so the top of it is spinning back toward you, called backspin. That makes the air rush faster over the top, so the weak push is on top, and the strong push underneath shoves the ball upward. The ball floats, hanging in the air, refusing to drop the way you expect, sailing farther. That is the long fly ball that seems to hover. Flip it, and spin the ball forward, topspin, and the push is now downward. The ball dives, dropping into the court far faster than gravity alone could pull it, which is exactly how a tennis player smashes a serve that plunges down inside the line. Ping pong, golf, cricket, it is the same invisible shove every time. Now let me be honest with you, the grown-up version, because the real world is always a little richer than the neat story. This whole thing depends completely on the air. Take the ball to the moon, where there is no air at all. Spin it as hard as you like, and it will not curve 1 inch. With no air to grab and shove, there is nothing to push it, and gravity just pulls it down in a plain, boring line. The air is the entire secret, and the ball needs to be able to grip the air a little, which is why a smooth, slick ball curves poorly, but a baseball with its raised stitching, or a tennis ball with its fuzzy felt, grabs the air beautifully. Those seams are not decoration, and here is the deepest way to see it. The ball is not clawing its way sideways. As the ball flings that air off to one side, the air flings the ball the other way, because every push in this universe comes with an equal push straight back. The ball throws the air one way. The air throws the ball the other. So here is what I want you to carry with you. The next time you watch a free kick bend impossibly around a wall or a pitch dart sideways and fool a batter completely, you are not watching a clever ball. The ball is just a dumb sphere with a spin on it. You are watching something nobody in that stadium can actually see. You are watching the air itself, a real, invisible ocean, get grabbed by the spinning ball, dragged around and flung to one side, and in return, shoving the ball the other way. The player never curved that ball. They just gave it the right spin, and then handed it to the invisible air, and the air did the rest. Every curve you have ever seen was a ball being pushed by something you could not see. So the next time someone tells you a great player just aimed the ball into that impossible curve, you can smile and hand them the real secret. Nobody aimed that curve. The air did, one side of the ball pressing harder than the other, and quietly shoving it across the sky. Now, I would love to know, down in the comments. Before today, did you think the ball somehow steered itself around that curve? And here is the fun one. What is the most impossible-looking curve you have ever seen a ball make? Come and tell me. And if you like having the ordinary things around you quietly taken apart until they finally make sense, subscribe and stay for more simple lessons from Mr. Y.